Okay, there we go. All right. Hey, Megan, since you were gone last time, do you want to read?
I would love to. All right. Question 1. Oh, okay. Question 1's by yourself. Answer was question 2. All right. Information. While you're required to work together on this quiz, each group member of the group must... Okay, we already know that. Okay. For the next 9 questions, we will review the PTC tasting study with different data. One of the 70 females in the sample, 52, can taste PTC. Out of the 59 males in the sample, 42 can taste PTC. And then the data is represented there. Let P1 be the proportion of females in the population who can taste PTC, and let P2 be the proportion of males in the population who can taste PTC. The research question for this study is given here. Is the proportion of females who can taste PTC different from the proportion of males who can taste PTC? Use the data in the table to find P1, rounded 3 decimal places.
Okay, that's 0.743.
Question 4, use the data in the table to find P2.
Is that 0.712?
Yes.
0. What?
712.
Okay, go fast.
All right. Question 5. Which set of hypotheses is appropriate for addressing the research question? H0 P1 equals P2 and P1 does not equal P2, P1 equals P2 and P1 is less than P2, P1 equals P2 and P1 is greater than P2, or P1 equals P2 and P1 does not equal P2?
It's A, the first one.
Yeah, because they didn't talk about lesser. It's just they're not saying, are they the same? Right, so then it would just be.
Yeah.
Awesome.
All right, information. Create a 95% confidence interval for P1 minus P2. Then put your answers for the point estimate, margin of error, lower bound, and upper bound. What is the point estimate for the 95% confidence interval?
Okay, so I missed this one. So will you guys put in 0.05 and see if that's the correct answer?
Absolutely.
Unless you guys come up with something different.
All right. Question 7. What is the margin of error for this 95% confidence interval?
0.154.
Okay, sorry, I missed that. 0.154.
Mm-hmm.
All right. Question 8. Input the lower bound, rounded 3 decimal places.
That one is negative 0.123.
Negative 0.123.
Uh-huh.
Question 9. Input the upper bound, rounded 3 decimal places.
That is 0.185.
Question 10. With alpha equaling 0.05, what decision do you make? Fail to reject HO, reject HA, fail to reject HA, and reject HO.
We're going to fail to reject HOA.
Question 11. Which of the following statements best describes the outcome of this data? There is insufficient evidence to suggest that the true proportion of females who can taste PTC is less than the true proportion of males who can taste PTC. There is sufficient evidence to suggest that the true proportion of females who can taste PTC is greater than the true proportion of males who can taste PTC. There is sufficient evidence to suggest that the true proportion of females who can taste PTC is different from the true proportion of males who can taste PTC. And there is insufficient evidence to suggest that the true proportion of females who can taste PTC is different from the true proportion of males who can taste PTC?
Is it C?
It's D.
D?
Yeah, insufficient evidence.
Insufficient evidence.
Yep.
But we failed to reject.
Yeah.
Okay, that's,
Isn't that complicated? Does that make
it
your
is.
head
It's
hurt?
very
Okay.
complicated.
Oh, they're too similar.
For the next 9 questions, you'll review the mortality rates and day of admission heart attack study with different data out of the 118,519 who had a heart attack during a weekday. 16,713 had died. Out of the 42,447 that had a heart attack on the weekend, 6,155 had died. Please use the data presented here. And there you have your heart attack outcomes. Let P1 be the proportion of patients who had a heart attack and were admitted on a weekday who died, and let P2 be the proportion patients who had a heart attack and were admitted on a weekend who died. The research question for this study is given here. Is the proportion of patients who had a heart attack and are admitted to the hospital on a weekday who die less than the proportion of patients who had a heart attack and are admitted to the hospital on a weekend who die? Use the significance level of alpha equals 0.0. Question 12. The conditions for conducting a hypothesis test are satisfied. True or false?
It's true.
Okay. 13. Which set of hypotheses is appropriate for addressing the research question? H0 equals 8, or P1 equals P2, and then P1 is greater than P2, P1 equals P2, and then P1 does not equal P2, P1 equals P2, and P1 does not equal P2, and P1 equals P2, and P1 is less than P2.
It's D.
Perfect.
Hold on. Guys, less than the proportion. Okay.
Mm-hmm.
All right. Use the data in the table to find P1. Round to 3 decimals.
That one is 0.141.
All right. Question 15. Use the data in the table to find P2.
That is 0.145.
Question 16. Find the z-score.
Z-score is negative 2.02.
And 17. Given the z-score. Oh, sorry.
Negative 2.02.
Negative
Yes.
2.02.
So negative 2.02.
Mm-hmm. Question 17. Given the z-score from the last question, which should you shade, the left or the right of the z-score for the p-value?
Goes to the left.
Question 18. What is the p-value for this test?
0.022.
Question 9.
0.022.
0.022.
What is the decision for this test? Fail to reject the null hypothesis or reject the null hypothesis?
It's a null.
We're going to reject it.
And then last question. Which of the following best summarizes the conclusion of this test? There is insufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die is the same as the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die. There is insufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die is less than the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die. There is sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on the weekday who die is less than the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die, and there is sufficient evidence to conclude that the proportion of patients who have a heart attack and are admitted to the hospital on a weekday who die is the same as the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die.
It's C. So there's sufficient evidence that
You die more on the weekend.
Yep.
Okay, I'll submit that one question.
Yeah, 6 is the only one I'm not sure of.
and 6 was wrong.
Was it?
So I was starting to enter it all in, and then I didn't get that far. So go back.
So you were say that one more time.
I was starting to enter in all the information on the, you know, the Chi, whatever, but I didn't get that far. Double check. Did anybody else start to enter everything in?
Yeah, I'm looking at it right now.
Right now.
Awesome. Oh shoot, I didn't save my answers. Usually I save them. Can you guys help me fill those out? Let's see.
For sure.
Number 1. Oh, I'm totally on the wrong test.
I was like, what?
That usually it says 1 and 2, and then we end on 3. Hold on. Group is, I think. Okay, so number 3 was
0.743.
4 was
0.712. Sorry.
No, you're good. Go for it.
number 5 was
A.
number 6. That's the one we don't know, right?
Mm-hmm.
Right.
And number 7 is
0.154.
number 8 is
Negative 0.123.
number 9.
0.185.
That's like, get my answer, sorry. Number 10
Is A. We're going to fail to reject.
and number 11 is the last one, right?
Is D. Mm-hmm.
Okay, and then true for number 12. And the last one for number 13, right?
Yep, D.
Okay, and then 14 was
0.141.
and Tim was used that in the table to find P hat 2. What was number
15 is 0.145.
okay, number 16,
Negative 2.02.
negative 2.02,
2.02.
2.
And that's negative.
Negative 2.02.
Mm-hmm.
Okay, and then this is going to be to the left.
To the left, correct.
And then the p-value.
0.022.
Okay. And then number 19
Is we're going to reject.
and number 20 was
C.
okay. How are you doing, Tiffany?
Okay, now where do we get the point estimate?
Oh my goodness, is that number 6?
Yeah. Is that on the sample test?
I couldn't figure that out.
I got 0.05 again.
You got what?
I got the same answer that we got wrong.
The 0.05?
Mm-hmm. I don't know what I'm doing wrong.
So did you do the sample proportion? Or
Okay, and how did you get 0.05?
yeah, that's what I'm.
Let me go back to it again.
Okay, I'm gonna start to.
So I Googled the definition of it
Yeah.
because I couldn't figure it out. And it says a point estimate of a population parameter is a single value used to estimate the population parameter. For example, the sample mean X is a point estimate of the population mean. So I guess that's not, I don't know, I still got it wrong.
Okay.
Let me see if I can find anything more.
Because I just looked up how to find a point estimate too.
Uh-huh.
So, because like when I typed in point estimate in the Wikipedia, then I typed in like how to and tried to follow that, but that doesn't really make sense either.
I'm still working on it too. Is there anything in the lesson with that point estimate?
I could not find anything.
Yeah, I'm looking and
I hate that. Figure something out. Point estimate. Okay, in the last thing it says, in the last 17, it said P times P hat is called a point estimate of P. A point estimate like P hat is helpful. We start with the point estimate of P and we add and subtract the center number and standard deviation. The point estimate for P is P hat. Doesn't that all make sense? No.
Don't trust me, 'cause I can't get it right.
The formula for the confidence interval for one proportion. So can we just take P times P hat? Or it says the point estimate for P is P hat. Hold on, let's see. We start with the point estimate of P and we add and subtract it. No, okay, that's the other. P times P hat is called point estimate of P. So what is P and P hat multiplied together? See, we don't even have all the P's and P hats and everything like that. Did you guys put it in the Chi? Or did you just do two?
I put it in the let me see.
Two sample Z test?
Into the two sample Z test.
Okay, so what'd you put for X1?
I put 52.
Okay, and then what'd you put for N1?
70.
Okay, and then what'd you put for X1?
You mean X2?
X2.
42,
and then
59.
59. Okay. Okay, so P hat is 0.743. If we times that by, well, there's really only other P hat 2, right? P hat 1 times P hat 2. Is there a P? No. Okay. If we did 0.743 times 0.712, it'd be 0.529. What does it say? Estimate it to? Or what? How many decimals?
It's everything's 3.
Does somebody want to try 0.529?
Yeah, I'll submit it right now.
Okay,
What did you say, 0.529?
529.
You said 0.529?
Yeah, I don't know if it's right, but we'll find out. I just took the P hats and times them to each other, by each other.
I'm going through the reading and I cannot find anything about that.
It's wrong again.
It is. It's on 17, lesson 17.
17? Okay.
Yeah, and it talks about it right on the confidence interval for one proportion. It says 2.1 honesty at medical school. And then it says we want to use the data from studies generalized to a larger population. We're not usually interested in particular individuals' responses. The reason the study was conducted to provide an estimate of the true population proportion, P times P hat, is called a point estimate of P. You guys see that in that lesson?
I'm looking through it. I can't find it. No.
Hey, is it because, do we need to change the type of test? No, probably not. You know how it said, I said P times P hat? The P in that is the population estimate or whatever, right? Or isn't the P hat the study sample, whatever? Know what P hat is? You guys all Googling away.
When is this due? Is it due Tuesday?
Yes.
Mm-hmm.
By 11, right? PM?
Mm-hmm.
So, let's see.
Huh. Okay, I think I found the point estimate is like the middle number of the, like the applet. The point estimate is the middle number.
Up at the top?
No, you know how there's like the middle line. So is that like 65 or whatever? You know what I mean? I can't remember what that is called. There's 1 point away from the midline is this, and then 2 is doing something, and then, you know what I mean?
Hey, stop it. No.
What the heck is that? A dog.
So maybe I'll show you guys. Like, according to what it said, that awesome drawing. Like, according to notes that I'm reading right here, this middle number is the point estimate on the center of the apple. And if that's the case, you look up what was the z-score?
This-
1.95. I wouldn't be here in the morning. There has to be an equation for it somewhere. And then put that back. So you're gonna. Okay, what do you guys suggest?
I don't know.
I'm so
can't
confused.
figure it out.
You guys want to just keep trying and set this tomorrow, and then we can text each other?
Yeah, because everybody submitted at once, right?
I didn't yet.
Can I re-get what was put in here? Because I lost it all when we.
Oh yeah, you did the same. Okay, Megan, you ready?
Yeah.
Okay, number 3, 0.743. Is my voice echoing?
Yeah, but it's
Uh-huh.
fine. I understand it.
Is everybody else's echoing?
I don't think so.
Okay, then maybe it shouldn't be reading this to her.
Okay, number 4, we got 0.712.
Did you just
Okay.
Number 5 was A.
Okay.
6 we didn't get yet. 7 was 0.154.
Okay.
8 was negative 0.123.
Okay.
9 was 0.185.
Okay.
10 was A.
All right.
11 was D.
Okay.
12 was true.
Okay.
13 was D.
Okay.
14 was 0.141.
Okay.
15, 0.145.
Okay.
16 is negative 2.02.
Okay.
17 is to the left.
Perfect.
18 is 0.022.
Okay.
19 is reject the null.
Okay.
And 20 is C.
Perfect. Thank you.
Uh-huh.
All right. Are we just gonna go to the next one then?
Yeah? Hold on, yes, everything up and I'll call you right back.
Okay. Okay.
Okay.